So the focus of Chapter 8 is going to talk about similarity. But before we get to similarity, we have to talk about proportions, because many times when we talk similarity, we're going to be actually setting up proportions. So we need to know how to solve it. So when we talk about a ratio, that's the quotient of two numbers. So for example, 5/3. Or you can write it this way, you can write it this way, you can write it this way, and you can write it this way. I'll tell you that this is the way that most ratios are written. But there are three other options. So one example of a ratio would be like slope. Now, when you put two ratios together and set them equal, they create a proportion. And the way that you solve proportions is that you cross multiply. Okay, so for example, it says on a map, the distance from A to B is 2.5 centimeters. The scale indicates 1 centimeter represents 30 miles. What is the actual distance from A to B? So I'm going to use my scale, which says that I have 1 centimeter representing 30 miles, and that's one side of my proportion. And then I'm going to set that equal to the 2.5 centimeters. So the units need to match, which means centimeters need to be on the top, and then x is in the bottom. Cross multiply and divide, and I end up with 75 miles for the actual distance itself. All right, now in a proportion, when you write out a proportion, there's 4 numbers that go into a proportion, or 4 terms. And the order of those terms is like this. So first term, second term, and then on the right should be the third and the fourth term. Now the first and the fourth term, the first numerator and the second denominator, those are called the extremes. Whereas the second and the third term, those are called the means. And this lends itself to a more formalized way of saying cross multiplication. But Theorem 59 says in a proportion, the product of the means, so that would be second and third term, is equal to the product of the extremes, which is your first and your fourth term. All that means, I'm going to write IE, that just means cross multiply. This is not one you're ever going to use in an actual 2-column proof. And what Theorem 60 says is that there's basically just more than one way of writing out a proportion. So if we start with PQ is equal to RS, then we have to say, okay, well, what kind of proportions could it have been for me to get those as the cross products? So as long as you have P and Q on one of the diagonals, and you have R and S on the other diagonal, what you'll find is there's multiple ways of writing out the same proportion, okay? And there's no right way or wrong way. So you do have a little flexibility with that. Now, where this is continuing to go is we're going to go over 2 items. One we've already learned about, and one is new. But we're going to go over geometric mean, which is your mean proportional. And basically, you're going to be asked to solve for the geometric mean. And your setup is always going to be a number over x equals x over the second number. These two values always need to be the same because it's considered to be the geometric mean between those other 2 numbers. So you have the geometric mean and then you have the arithmetic mean. So the arithmetic mean is the same as what you would have done in an algebra class. It's the average. So to find, if you're ever asked to find the geometric and the arithmetic mean between 2 numbers, arithmetic's the easiest. We're just going to add the 2 of them up, 3 and 27, and then divide it by 2, and you get 15. Whereas geometric, again, here's your setup for geometric. So you're going to take your first number 3, put it over x, equals x over your second number, which is 27. Then when you cross multiply, you get x squared equals 81. So x could either be plus or minus 9. So both of those answers needs to be given. Don't just give the positive or the negative. You have to give both. All right, so let's continue with some of these. So it says if 3 over x equals 7 over 14, solve for x. So cross multiply. You get 42 equals 7x, and that means x is equal to 6. Final answer. Next one says find the 4th term of a proportion if the first 3 terms are 2, 3, and 4. So remember, this is your first term, this is your second term, this is your third term. So if this is your 4th term, that's where the x needs to go. And then it just becomes cross multiplication, 2x equals 12, which means x is 6. Next problem says find the mean proportional. This is the same as the geometric mean. So you will see both of these ways used in problems. So it's either mean proportional or geometric mean, but it means the same idea. And remember, the setup was it's a number over x equals x over the other number. So 4 over x equals x over 16. Cross multiply, you get x squared equals 64, which means x could be plus or minus 8 for that. Now the last type of problem that you're going to see is going to ask you to solve for a particular ratio. So it says if 3x is equal to 4y, let's find the ratio of x to y. So if we want the ratio of x to y, what that means is it has to be x over y in the end, equals something else. That's what we're looking for. So first thing I want to do if I want to keep x in my numerator is I got to get rid of this 3. So I'm going to divide by 3. So when I do that, if I write one more line here, I get x equals 4/3 y, or 4y over 3. So now my other issue is that y. I got to get that to the other side. So I'm going to divide by y, and I'm left with x equaling 4/3 for my final answer. Now, if the question asks for a ratio of y to x, then it would be 3/4. You have to make sure that you're writing it in the order that they are intending it on it being written in. All right, for the next one, it says, is x over y equal to a over b? Is that equivalent to x minus 2y over y equals a minus 2b over b? Well, what I would do is I would cross multiply.